I won't be able to shout as much as I would normally want to, but I hope that you can hear. Good morning again. And welcome. My name is Dr. Nancy Miles Bafoji. I'm trying to put together a quick mop-up for you. I want to make it as crisp as I can for PHCL204, Elements of Formal Logic. Just to build your confidence a little bit more as you prepare, first of all, for your interim assessment, but more importantly, for your final exam. The interim assessment, as I said last time during the class for City Campus Test, I told you that it is just MCQs. You're going to do multiple choice questions for just about 20% of your final in the course. But it is going to be a good model for you to anticipate the kind of questions you'll be asked in the final exam. MCQ, so you can easily pick without having to find the symbols on the keyboard, whatever you at the exam center, since you're working online. Okay, but you very much be interested in how you are able to write them out and construct and create and analyze, compare from story problems, Venn diagram representations, or some of the things. And those are the ones that we have left. The substantive content we are done, and you'll see shortly. Okay, so on your course outline, this is the course outline. Excuse me, I'm projecting. Special students, you are very much involved in content, except with the symbols, which we have to understand. So lecture 1, you're supposed to know the pedagogical matters, assistant, group reps, TAs, attendance, whatever. The substantive content starts at lecture 2, propositions and non-propositions, and by now you know which ones are stating and which ones are not stating. When you have a linguistic expression, which one is stating, saying something that can be true or false, and which one is not. Okay, atomic and compound will be next. Now that you know what is stating, where my statement doesn't encompass another one within itself, then you have an atomic, that one, the smallest indivisible part. Okay, you can further divide it into another. But where it is a compound, it means you have another statement within the given statement. You can get another statement from what has been given. So, for example, if I say today is not Friday, it is a compound because I can get today is Friday from it, vertical or not. Okay, and so if you study, then you will pass. You studied is a statement. It can be true or false on its own. You passed is another statement, stuff like that. So, based on which compound you're dealing with, you can then tell the truth conditions of that compound. And that is what the lecture 3, bullet 3 is trying to tell you, understanding truth conditions of compounds. What addition means is not the same as what subtraction means in mathematics. Therefore, when I say or, I haven't said and. So the way the connective or operates on its disjunct is not the way the connective and operates on its conjunct. Okay, and so we have done them. I just want you to know that you will be expected to give an account of yourself on that. Okay. Then English words that approximate. It's like if you say the product of the sum of 2 and 3, the product of what's the difference of 9 and 6. Difference means subtract, product means multiply, sum means add. That is also happening in logic. When I say if then, when I say or, when I say since, these are all indicative of specific compounds. And your page 46, the last page that gave you quite a good number. We have used so many in class. If you were participating in the lecture, this mop-up will not be helpful to someone who has been absent throughout or doesn't engage content. I got one message or so. Please, I had traveled, so I've not been around. I just came and he said, you are confidently telling me that this is week 9 ended. Monday we start with 10. God willing, we start with 10. Of a 12-week semester. So you can't be passing, not for courses like this. It won't work. And the university has don't let me know that you just landed. But I'll pretend I don't know you just landed. Okay, just fill the gaps and catch up. Don't make me even know that you just landed. I'll know on my files, but don't come and say it to my face as if it's something you should be proud of, regardless of what the reason is. Academia. Okay, so those like that won't find some of the things we are saying useful because if you don't know what conjunction is, how do you understand its truth conditions? But a good number of you, about 80%, 90%, are constantly in class and following content. I may even say 96 or something percent because I check attendance and I do that regularly. Okay, in class participation. So let's continue. I'm just helping those who have been in the content, like who have been in the course, I should say. Sorry, I had to take a sip there. And they need to organize their thoughts around what has been done so far. Okay. So you should know how to create your own compound, not for the I, because you won't construct them, but for the final exam, substantively, you need such things. Okay. You should be able to tell when the formula is atomic and when it is compound, what type of compound, and what the sub-formulas are that have been put together to create that compound. You must be able to know dictionaries, lecture 4. Dictionaries. Your dictionary is what the raw material you work with. So if I say today is not Friday, yet I'm going to church. Look at the atomic formulas that have been put together. First one is today is Friday. Second one is I'm going to church. Then you symbolize it by saying not Friday, so not yet going to church. Yet is conjunction. So not conjunction. See, that's what I've said. Today is not Friday, yet I'm going to church. The F is what you have to symbolize. In other words, create a dictionary for it. So that when I bring it down, I'll come and negate that F. You don't put compounds or connectives or logical connectives in your dictionary. You don't. If you do that, you have created a problem. You need to get the raw material. So if you study them in the past, what are our atomic formulas from which we have created our dictionary? X studies, that is your P. Q, X passes. Now you can see P, if you step there, so S conditional P. There, that you see that. Another one. If you are not my friend, then you won't tell me the truth. Not friend, then not truth. But the dictionary must say, let F be equal to what? X is my friend. Let T be equal to what? S tells me the truth. Is that they are positives because you extract the atomic. Now, when you have your dictionaries like that, then you can create the symbols. The symbolic version will capture the negation. So that when I say symbolize, then it will be not friend, so not F, then not T. But the dictionary cannot have the nots. It must just be purely atomics. Also, a quick reminder for some who may not have taken a note of that. So that's how we create dictionaries. A reminder there. To be able to identify well-formed formulas. There was a whole set of exercises on that. You shouldn't drag it. Lecture 5 on your screen now. You should know how to display, formulas on a truth table and then do the analysis to know when it is consistent or inconsistent, the type of consistency. And logical equivalence rules can also be tested on that. Truth tree display, you know that you can display on a tree now. The tables are not trees. I don't think you have to be writing out stuff, interim assessment, but you do that in the final exam, obviously. Okay. And there again, you learn how you use trees to tell us consistency, inconsistency, tautology, contingency, logical equivalence. Then testing for validity, we polished up the last time. We said if you have an argument as a set of formulas, the way you test for consistency, you do same validity, except that for validity, I need to keep myself warm, so bear with me. For validity, you'll have to negate the conclusion before starting the testing. So you have a set of formulas. I'll show you a few instances from your workbook itself, and then we will be done. I give you formulas. So P conditional Q, the second one, Q conditional R. Therefore, S, for example, 3 formulas. Then I tell you the S is your conclusion, because you're going to use it to test on validity. Remember, you need, if it's testing for the validity of an argument is a set of formulas, one of which is the conclusion you are drawing from the others, which are other premises. So when you have an argument, you have a set of formulas, one of them is your conclusion all the time. If I'm testing for the validity of an argument like that, I'll need to know the conclusion so I can negate it and decompose to test. If I negate that conclusion, I decompose and the formula becomes inconsistent. Everything closes down there. Then it tells me that my given formula is what valid. It is valid. That is why when I negated the conclusion and decomposed, the system said, no, something has gone wrong up there. That is how it tells you, no. It closes everything, doesn't allow you to continue, because they want you to go and change something wrong that you have done up there, which is what you have negated the conclusion. So when you negate the conclusion and decompose and it becomes inconsistent, that tells you that the formula, the original formula, is what valid. That's why when you negated its conclusion, it generated a contradiction. I've done this already. I just needed to help you remember. Testing for validity, therefore, uses the negation method. You negate the conclusion and do that. So we can look at when we do the last lap where we are practicing more. Tell your IA, we will be testing more. Make campus, city campus, we did 1 or 2 of them. Main campus, also we practice validity. Okay. So we use the rules of inference, modus ponens, tolerance, hypothetical syllogism, constructive dilemma, conjunction. They are all on that page, second page. The second half of the page that has your rules of equivalence. The second half has those rules. We'll use them to practice validity a bit more. You can start doing that tutorial, which is can be practicing with you. Then lecture 8 wants you to know the validity of equivalences. That simply means find any equivalence. Suppose I gave you commutation and I said demonstrate or prove that commutation is a valid equivalence. What am I asking you to do? Just state the rule of commutation fully, the complete rule, and test to see if it will generate a tautology. So you should know the method of testing for tautology. First, establish it's consistent. That is on the trees. Establish that it is consistent by when you decompose, there should be an opening band. Then negate the consistent formula and test to see if it will generate inconsistency after I negate it. If it happens so, that tells you the formula is tautologous. That's why when you negated it, it has become always false. That means the original is always true. See that? Now, if it becomes a tautology like that, then it tells you that you are dealing with what? A valid equivalence. What is at the left side of the biconditional is the same in value under all possible truth conditions to the one at the right. They have the same truth values under all possible truth conditions. That is what logical equivalence means. And therefore, when you generate a tautology, that's a repetition throughout. It tells you that they share the same truth value and all possible truth conditions. That's why those two parts of the biconditional generated a tautology. Okay, proving the validity of equivalence. That's how you do it. Then exercise drills. That's it. Look at the content proper. Still in your web, so see some examples, some things that we put there for you. Propositions and non-propositions. You see the declarative sentences, statement, blah, blah, blah. Okay. Why they are true valued? These are there. I'm not going to tell you what is there like this. After all the many weeks you've had together, you just need to sit up a little bit more so that you can get your perfect 20 over 20 in the IA. But more importantly, so that you are well built up for your final exam. We have 2 weeks to go. You are ready. So you are learning both for the exam and for the IA. Okay. Exam is 70%, 70. I want you to get 68, 69. You dash me one thing. Okay. So truth values, Aristotle's laws of thoughts. My special student, no excuses. These are not symbols. You should know them. Okay, atomic and compound. You said all that. I'm just walking you through for you to see that. So much. Identifying the atomic formulas to create your dictionaries. Look at conjunction. What are you? Simple translation exercises. Women are compassionate. I'm looking at the B. Women are compassionate, but men are courageous. This is a conjunction with both conjuncts being conditional. I'm saying if X is a woman, then X is compassionate. But if X is a man, then X is courageous. That's B. So your variables that you work with in creating your dictionary will be P, Q, R, and S. There will be 4 variables. X is a woman, X is compassionate, X is a man, X is courageous. Then you do if woman, then compassionate. So if W, then C, into bracket, conjunction, if M, then something else. Because we have a C for compassionate, we may want to use a Q or something for courageous. So you are done. He who never speaks never errs. If you do not speak, then you will not err. That's what I've said. If not speak, then not err. So we must have X speaks. It's one of our dictionaries. X errs as another. You see that? Then we say if S, then if not S, then not whatever. Not err. The variable used for err. We could all go on and on and we need to practice. These were all given to you as group work. Some of them individual. Quizzes are read while outlets are blue. I'll copy the answers from answers with that anatomic formula. And so on. Okay, let's move. So here are expansions on the principles. State the principle of non-contradiction well. At the same time and in the same respect is crucial. Understanding one statement cannot be put true and false at the same time and in the same respect. If you take that condition off, you haven't captured the principle of non-contradiction very well. I can be here in person, but not here in mind. So you have to put the caveat there to capture it well. We have gone through that in class. We know the truth conditions, negation. I can do a lot of story problems from here. Remember the woman, the practice questions we did in class. The woman says, if my boy gets an A in the first class or something, then I'll take him to Dubai. He doesn't get the first class, but mommy still takes him to Dubai because he topped his class maybe with the second class. Now, what happens to what mommy said? Is mommy's statement true? These are practical applications of the truth. Connected, you should be able to do them easily. Inclusive sense, exclusive sense. Special students, don't forget that as well. They are not symbols, so don't give yourself any excuse. All right, then conditional. Because it is a PDF that has been converted, some of the writings, as you see them, like the spelling of conditional. It's fine in your workbook, but I wanted it to be projectable easily. So I'm using the word version. That is why some of the spellings are off. Oh dear. Okay, so we have conditional, by conditional, the truth conditions. You can give examples of each. Then we translate from symbol English to symbols. Today is not a holiday. The dictionary will be today is a holiday. Let P be So I will let P be today is a holiday. So that the negation of that is what you symbolize, not P. To represent today is not a holiday. See that? Yeah. One more. Either you will pass the exam or you will not pass. Your dictionary will be P is equal to X will pass. That's all you need for example 3. Then the symbolism will be P, that is S will pass, disjunction, the V, the small V for vulture, see, and not pass. Here that. So P, disjunction, not P. That is what 3 represents. Dogs bark, but ducks quack. Question 5, look. Dogs bark, but ducks quack. That's a big statement. It is. If X is a dog, then S will bark. And if X is a duck, then S will quack. It's a big compound. It's not a baby statement. If you don't know, you think it's atomic. No. It's a conjunction whose left conjunct is a conditional as well as its right conjunct also being a conditional. We could go on and look at this. If women are compassionate, then men are courageous. Women are compassionate. Is itself a conditional? Men are courageous. Is itself a conditional? And the two conditionals have themselves been put together with a conditional. So this is if woman, then compassionate into bracket. Or then if men, then courageous also into bracket. See that? You should be able to do a quick translation of them. The revolution, example 12, excuse me, 13. The revolution will succeed if and only if the time is right. It's a biconditional. Biconditional is both sufficient and necessary. It's a sufficient condition as well as a necessary condition. Look at 12. No student cheats in an exam. If X is a student, then X will not cheat. I think you know them. If you don't, it's a good time to remind yourself quickly because you will need to account of yourself. And so from there, we go to identify well-formed formulas. Look at 4 up there is well-formed, but 1 and 2 on your screen are not well-formed. You don't know which one is the main connector. There is no clarity of who the boss of the house is in terms of connectives. That's what makes them non-well-formed, and therefore you will need to correct them. Here, we ask you to describe the formula and its sub-formulas, I think, after you have determined whether it is well-formed or not, and to tell us which compound it is, if it is well-formed at all. Look at example 1 on this exercise set. I says, what formula is that? It is a conditional whose antecedent is what a disjunction. Simple. But how about II? II is a disjunction whose right disjunct is a conditional. III is not well formed. You don't know who the master is. Is there a disjunction or conditional? And so on and so forth. Okay, you can practice them. Which lesson 4 looks at truth table analysis, which you know very well. I've corrected this now. In your workbook, there was a mistake somewhere. I think it was this. We have done it in class. So false for a disjunction cannot be false. So excuse me, cannot be true. Check that in. Those who haven't corrected. When people land and they don't. Okay, so false is false for a disjunction. But we can say that for conjunction for obvious reasons. For biconditional false is still true. And you know why it is so. They share the same truth value, then it's enough to make them true. Let's descend. I don't want it to be too long. So more translation exercises for you. Now down here, you see why it's difficult to translate from natural language. Wherever there is true love, there is sorrow. What is it? It's a conditional. If there is true love, then there is sorrow. That's what the person is saying. Humans are mortal. If X is a human, then X is mortal. And stuff like that. Look at either you study hard or you fail. S or F can become, if X does not study hard, then S will fail. And you see how material application works. So from this junction, you can create a conditional by negating the first disjunct. Okay, these are equivalences for you. Think that by now people are well confident in the equivalences. Not all of them, but most of them. Okay. What is equivalent? The two formulas are said to be equivalent when they have the same truth values. This is it. Same truth values under all possible truth conditions. Excuse me. Under all possible truth conditions. Simply put, they are said the same thing differently. Okay, so they're saying the same thing differently is what makes them logically equivalent. Whatever the left is saying is what the right is saying. I kept using exchange rates to show you that, or changing our currency. I give you 50 Ghana cedi notes, you give me 10 5 Ghana cedi notes. The value is the same. So in your screen, look at 1. 1 is T Morgan. Look at 8. 8 is commutation. It is by commutation that the two formulas there can be said to be equivalent for 8. What do you think? Nice. I see transposition there. So you got to do that one so that when you see 2, you know that that's association. Look at it. I shared what I got from T. Clifford. I mean, it was already in your workbook, but we got a very clear one that we quickly shared on your platform on the rules of replacement. That's the equivalence rules. They are there on your WhatsApp platform. Easily look at it so that when you see 3, look on your screen, you can tell that that is for tautology. The equivalence rule is what is operating there. How about 4 is your baby? From P conditional Q, you get not P disjunction. I'm not telling. You should see that 5 may not immediately represent as one of Copy's rules of replacement, but you can check to see if it's a valid equivalence. That is, if I have P disjunction Q, can I say that it's the same as not P conjunction, not Q? So you can test it to see even if it doesn't fall under the rule, the replacement rules. I don't know the name to give to it, but is it a valid equivalence? How do you check it? Put P disjunction Q on the left side of the biconditional to bracket that. Then put not P conjunction not Q to the right side, also in bracket. Now you have created a well-formed biconditional. Test the type of consistency. You know how to test for that. If it becomes a tautology, then you know that you had a valid equivalence there. Okay. The formula you use to work for all the possible truth conditions, you know, 2 raised to the power n. That's what is on your screen now. To help you plot on the table and to tell you that this one generated a tautology. So it tells you that the equivalence there is a valid one. We know already that our equivalence is association. See, same connecting, same arrangement of variables, PQR. What has changed is just the bracket from the last 2 to the first 2. That's association. If it's a rule of equivalence, it will be a valid equivalence. But sometimes you don't know it to be a rule. So you have to just know how to demonstrate, test for it. How tree analysis, your baby, love it. Look at that. You know how to do all these already. Pi conditional, either they are true together or false together. The negation will negate. When you do a negation of a biconditional, the negation goes diagonally. So you negate not a Q on the left and negate P on the right, and that will be fine. Where is it? This is it. See that? This is what I'm talking about. Look at the right side there. We want you to always know that the P and Qs you see in the formula could themselves be compounds. It could have been P conditional Q, could have been P and Q, or conditional S disjunction Y. It is still a conditional. It just happens that its antecedent is itself a compound and its consequent is itself a compound. Okay? Yes, that practice, you know, just to remind you. Then analyzing the tree. An open branch means consistency. All branches closed means formula is inconsistent. So look at this is inconsistent formula on the tree. When you decompose this, they will generate an inconsistency. Keep looking. See example 1, created an inconsistency. Then we move on to types of consistency, tautologies, and contingencies. How do you do it? Negate the whole formula that was originally consistent. And if it becomes inconsistent, see how repetitive I have become. I keep repeating. It's intentional. The monotony. When I keep repeating and repeating, some learn that way. That is why. So at this stage, there are some of the concepts when I ask you, even whilst you are asleep, you should wake up your answer and keep going and go back to sleep. You don't need effort because it has become monotony. Your boss emanating. So you have overemphasized them. You shouldn't waste too much time on such. Okay, so these are more practice questions, and then I gave you testing for that is more consistency. Now testing argument, that set of formulas for validity. You must always know the conclusion, negate it, and then decompose. Okay. And negate and decompose and everything closes. This shouldn't confuse you. Okay. Especially with the formula. Therefore, the conclusion. Then pick the conclusion, brought it down here, negated it. So you can ignore the keyword side and just decompose. Okay. And if everything closes, then it is valid. If you negate and everything opens, or there's an opening still that it has become consistent, then it is not valid. So this one, the conclusion in example 1 is not kill. That's what is given. If you're going to work with it, you work with kill. The second one, the conclusion is kill. So you negate it with. The third one, the conclusion is P conditional, not P. The last one is your conclusion. If you are not intentionally given a conclusion, then the last one, the last formula in your set of formulas is the presumed what conclusion. Therefore, for example 3, the conclusion is P conditional, not P. And if you want to negate that, you have to put P conditional, not P into brackets and then introduce the negation in front of that. If you don't put them into brackets, you just do not P conditional, not P. You have just negated the antecedent, and that is not correct. Negate the whole conclusion and decompose. If it generates an inconsistency, then you are sure it's valid. Look at example 5. There should be a comma here. So the first formula is P conditional, open bracket, Q conjunction, R bracket. That's the first formula for 5. Okay. But the next formula should be negation of open bracket, P conjunction, Q bracket, close. So they put comma, and R then becomes the conclusion so that you can negate the R to work. Again, look at 6. If the first formula says P conditional, Q disjunction, R, that is not well formed. If you were working, we'll have to clarify either it's a conditional or a disjunction by introducing parentheses. So that becomes one of the formulas. And the second one, the conclusion is not R. It is the not R you negate to become R and work with. Question 7, the conclusion is P disjunction R. So you know how to do the negation. Put P disjunction R, the whole thing to brackets, and negate. And you see that the Morgan will show you how it will look like in your decomposition. On that note, testing for validities, I've already told you how to do it. Put the two, if it's, see, this is it. Look at when you do this, see that wherever this is true, this is true. Wherever this is false, this is false. They share the same truth value under all possible true conditions. So if the next column puts the whole formula P conditional, Q by conditional, not P disjunction, Q here, what will happen? You see that it will be true to the end, like we saw with association earlier. Okay? Making it a tautology. If you use the tree analysis, it will be same. After decomposing to show that it's consistent and negative. And you see, there we go. See, negation will generate an inconsistency, meaning tautology, therefore a valid rule of equivalence. So we will practice with the rules of inference, rules of replacement for testing for validity and demonstrating the validity of equivalence. You have to know this, what I'm projecting now, by heart. I'm telling you that know the rules, both inference and replacement rules, or inference rules and equivalence rules. Know them offhand. Why? You'll be held accountable. Not only in this course, but subsequently in deductive learning. You will need it to be able to put your reasoning and analysis all together. They are copies rules, and they are very basic rules that you must easily have. How many I questions? I'm thinking of 20 marks, but the questions, I don't know, maybe 40 questions, each 0.5. Maybe I'll have to fine tune that this evening. Hey, doc. I look at the class. Okay. I look at the classes, and I think I have relatively very good students this year. And so your questions will be fine. Okay, you will do fine, don't worry. These are the rules. This is a bit blurred and not too well arranged compared to the one we have shared on your platform. You would want to use that. Look at the rules of inference. Very easy. So think around it. At this stage, I think I have to be concise. I'm planning on giving you 40 questions to answer. MCQs throughout. Each will be worth half. That's 0.5. So that by the time you finish, it will count for 20 marks. Okay? And they are all MCQ. Very easy. Please go to the exam center knowing that you're going to do independent work. Okay. The other 10% will come from all that we've done in class. And all that we've done in class that you have actively engaged in will also contribute to augment your final exam. Your final exam is over 70, no problem. But sometimes someone could get 25 over 70. But if you look at their progress, you may be able to squeeze out a 12 mark or a 10 mark somewhere to support what I cannot assess you solely, substantively on just what you did in 2 hours. When I know how you have progressed over 12 weeks, see that's my philosophy. So I won't alter it totally, but it will count. How much? So that's someone that just doesn't descend today and come and sit there and come and chew, pour, pass, and then forget it. No, it has to be ingrained in you. And how do we check that? We check it formatively and cumulatively. So 20% IAS, 10% continuous assessment in class, +1, +2, yes. 70% final exam, yes. That's the criteria. But the rules are made for man and not man for the rules. So your exam may turn out to be, if you get your 60 over 70 in the exam, oh, glorious. We'll add it to I.A-Final or I.A-Final. And just in case we need some 2 marks or 3 marks to move you to the next level, we can. Not when you did nothing. I can't check your progress. I don't know. At the end, the final exam to go and bomb or blast. You see, that is not too pleasant. So keep working, keep attending lectures, keep participating. Let us know what is inside your head so that just in case, God forbid, Johnny broke your heart and so you went and you were a bit distraught and it affected you by some 20 marks or something. It will not pull you too much down because we know you and what you are capable of being. And we will know you by prophetic grace. We will know you by your participation in content. I wish you all very well. I pray for you for good success. May your efforts yield abundantly. And may God grace you, not only in this course, but in all your courses. My name is Dr. Nancy Miles for GMP. The best. And take care. Bye-bye for now.